Carlo? Ce ne sono tre. Corongiu, Experience, tu, Giacomo.
Allora, carichiamo qua.
Io non so, se non ha caricato un po' sbagliato.
No, come scusa, se ti ho detto guarda c'è la tua di Manuela, manca quella di Giacomo, può essere il posto sbagliato, no? È quello. Okay. I don't know why my presentation is not in the... By a charge, I have also tested in the speaker corner, anyway. Anyway, I charge directly here. Okay. Not this one.
Ok, So welcome to this workshop of the LIFE+IMAGINE project. My name is Giorgio Saio of the GZIG Association. I am the project coordinator of this project. This is an official event of the project that we use normally this event like in Inspire to promote and to transfer the outcome of the project, and we kindly ask you to just to put your name and your email so you receive some more information after this conclusion of the workshop, and also you will have also the opportunity to visit the inside part of our website with the training section modules that I will show you later. So if you can circulate that. Many thanks. So we will start with just presenting the result of the EM Plus, the project. You have here the agenda of this meeting. We have this welcome address, then we will present which are the results of this project that deal with the integrated coastal area management application. We selected some of the problem of the coastal area, and then the following presentation will give you the idea of what type of problem we have considered. We will consider then from our colleague Giacomo Martirano of Epsilon Italia the methodology for the Inspire harmonization and validation of data from the scenarios that we have considered for this project. And this is important, is a methodology that we apply in other European project that our association is managing. So in this type of project, the data are quite important at the kernel of all to get the result, and Giacomo will present our approach to data. Then we will see from Emanuela Caronjo from Consorzio Lama the experience in landslide data harmonization and the critical issues and the solution. And then finally, Carlo Cipolloni from ISPRA, that is the Italian National Environment Agency, will present the advantage and the potentiality of Inspire data in environmental impact analysis. Then we will have a conclusion, then also from your contribution, so listen very well what we are saying before, how LIFE+IMAGINE could be applied in other geographical and environment contexts. So just get your impression of that. So just do 2 words about the organization I am coordinating, the GZIG Association, Geographic Information System International Group, that is a European network, is an open European network dealing with innovation and technology transfer in the field of geographic information. Our mission is to share experience among university, enterprise, companies, national and local bodies, stakeholders. So we group the different types of stakeholders that work in the field of geographic information. This is an open network. All the organizations that are interested are very welcome to share and bring your experience in this network. And then we promote the participation in initiative of common interest, in particular in different European projects. In the field of education and training, international cooperation, research, and regional development. We promote thematic area like coastal management, and this is a project where LIFE+IMAGINE started, but also in other thematic areas like water, resource management, network conservation, and so on. Since here, we follow Inspire, and we made a lot of experience in application technical solution in line with the European directive, in particular Inspire, but also SACE and so on. Our latest project, and you will find here in the folder I distributed before, we concluded the EM Plus project, environmental service for advanced application within Inspire. We create an interoperability stack from the data harmonization, semantic harmonization, service integration, and so on. So this all what is a framework to deal with Inspire, with creating application and so on. Here you will find a sheet of this project, and the engine of this project has been the startup for other projects like Geosmart City. We had a workshop yesterday in the field of open geodata for innovative service and user application in the context of smart city, green energy, and integrated management of underground scenarios. But also our mission is also to transfer the knowledge. And then we have we had the project called Invite, leverage inspiring knowledge into vocational innovative training. And we set up a set of learning models that will be also presented today at the lunchtime in the training for Inspire. We will present this package, and you are all very welcome to participate. We are also participating in another ICT PSP project called iLocate, indoor-outdoor location, for asset management through open geodata. Currently, we started a project in Erasmus Plus for an alliance university enterprises for enforce the cooperation through real cases, the GI cases, where the company expresses their needs for knowledge from the academic, and so that there will be a strong cooperation network to foster this type of collaboration through real cases. You have the last sheet is related to this project. But today we are speaking about LIFE+IMAGINE. So, this LIFE+IMAGINE that deal with integrated coastal area management, deal with an approach to look at the different European directive for what is in relation with the coastal area management, and then we will speak about Inspire, of course. We will speak about Copernicus. We will speak about SACE, Shared Environmental Information System for Europe. This was a call of 2013 related to environment policy and government as a strategic approach. So the topics was to enforce a knowledge base for the implementation of new environment and environmental data policies, the Inspire, SACE, Copernicus, with the promotion of information system for the strategic planning in a coastal area. Just an overview of this project: supports environmental and data management policies related to coastal planning and governance, through methodologies for environmental analysis, the integration and harmonization of multi-source data. So you can imagine that in the coastal area, there is concur a lot of different type of data sets from marine, the line, coastal line, the coast itself, the use of the coast, of the land use. There is many environmental problems there. So, and the mission is to provide new and on the information to support the planning, the decision making, and environmental reporting, with particular reference to 3 scenarios. One is soil consumption in coastal zone through 2 pilot sites. One is landslide in coastal zone, 2 pilot sites, and then another scenarios that come natural in this project, that is exactly the integrated coastal zone management scenario. We have implemented the web service infrastructure coming from what I told from previous projects as well. So we may benefit from the experience of a successful project, integrating in its own architecture specification and following the indication of ICZM sales and the data from Copernicus. We have the scenario of soil consumption in 2 pilot areas in Italy, in Toscana, in Versilia, in the north of Tuscany, and in Liguria region in the area of Tigullio, where several municipalities are involved in this scenario. About the landslide, we had in the north west part of Toscana the basin of the Magra River, and in Liguria we have the Cinque Terre scenario that we have maybe you heard about that, we have a serious landslides phenomenon in 2011. And then the integrated coastal area scenario that is in some way connected to the put all together many information about the sediment budget calculation, and you see here the different after a strong phenomena that we had in 2011, for example. We define different use cases, 3 for landslide, informing and motivating citizens, landslide and the transport network, landslide and agriculture and cultural heritage. About the soil consumption, there is the 3 scenarios in soil consumption calculation at the national level, analysis of the degree of imperviousness for the calculation of landscape metrics at the municipality level, and land cover flow reporting. For the integrated coastal use case of integrated coastal zone management, we have just the use case of sediment calculation. When we see the outcomes of this project, we provide the infrastructure that provide new, usable, and accessible information for, and that means better assess the impact of landslide and land consumption by calculation in which measure the investigated zone is affected by this problem, mitigate the impact through the prevision and the monitoring of this problem, improve and in long term reshape the planning process by proposing intervention aimed at removing the impact. So you can see that on the coastal area there is plenty of data set that have to be analyzed and with a methodological way, in such a way that can be integrated for analysis. And that is what the project aims. And we will see in the next presentation what is the result of that. Just some words about the architecture. You will see that there is many data coming local, ICZM, Copernicus, statistical data, and so on. we had the engine web service with a web processing service for the landslide, from soil consumption and for the sediment budget. We have this is the infrastructure. We have the pilot, and then we produce thematic map indicators for planning, decision-making, and reporting. So this is, in very short, what is the project. From more on the technical point of view, we will see that there is different users that raise a problem, 7 use cases, 3 scenarios, different data, and then we will develop this technical tool for that. Some of example you will see here for the part from Regione Liguria and Toscana, and then we will see the different analyses that are being done through the 3D client portal. About the web service, we have ingestion services that are to load, process, and store the data provided by external sources, by stakeholders, and by other architectural service, data access service, catalog service, and processing service. In particular, process the input data, both geographical and alphanumeric, and produce an output according to the specific algorithm implemented. Before going more in the technical presentation, I would like to say that the project will have also organized the so-called LIFE+IMAGINE training framework that is accessible from the project website to support the stakeholder to really enter in the knowledge produced by the project. This is part of our policy of the association to transfer the knowledge, to provide the information through learning courses, and this comes from far away when our policy was to support training for GI-related directives, Copernicus, SPY, SACE, Water Framework Directive, and through the development of several projects in the past, Content Plus, ICT, PSP, we afforded the problem of data harmonization, data specification, service provision through a different type of project. Humboldt that developed the AIL data transformation tool, that is one of now the most important used by many organizations, NATO Plus and so on. But all of that has been based on our experience on a Leonardo da Vinci project, where we create the concept of catalog of learning modules, catalog of training modules, the possibility to create customized training path according to the different needs. And this is coming now through the recent project like German City, Linvit, and Implus that you will see here the training framework of all of this project, and we have also developed for LIFE+IMAGINE that. The training package consists in the training framework, a training package that is the catalog and all the information related to each courses with the access to the entry point to access the learning platform where there is the modules. The modules are organized in different levels. We call the background knowledge, that is the knowledge needed to work with the team of the project, and you can see here there is introduction to INSPY, basic of INSPY data specification, data harmonization, and so on, as an example of data transformation and so on. So it's a block of modules that we use for different projects, not only for LIFE+IMAGINE. We also include here Copernicus due to the fact that this project strongly deal with Copernicus. We had the thematic knowledge about the risk management and geological determination. And then we will go through what is the infrastructure and the scenario application and use cases. So for each of these, there is a specific training model. This is available through the website of the project. You go to the training, and then you find the list of the modules. And for each module, for example, Introduction to Inspire, you have the metadata, and then the access to the module. The metadata is structured in all the modules are structured in the same way. So we have module name, source, ownership, abstract, structure, learning outcomes, intended outcomes, prerequisite language, and so on. So all is well documented. So before going to the module, you will see what you will see. And then accessing to the module, you have the self-learning material in different format, presentation, test lecture, audio presentation, and so on. So you are all invited to the training framework. And so if you have signed that, you will receive a message inviting you to join this framework. So you will find also the leaflet with some information and so on. So now we go to the next presentation, and I invited Giacomo Martirano that will speak about how is our approach for data, because here there is plenty of different data sources, and it's interesting the approach that Epsilon Italia has developed.
Okay, good morning, ladies and gentlemen. And in this presentation, I will present how all the data component of this project that Giorgio just introduced and presented to you have been dealt with in relation to Inspire. Because you can imagine how many data, how many teams, how many issues have been encountered and solved. So this is the outline, just an overview of the context of Inspire data harmonization, and then some details about few examples related to land cover raster datasets, which were Copernicus datasets, and then a couple of examples of the use of the combination of statistical units and population distribution that we used also to, I think, an interesting approach, how to transform, according to Inspire, a set of environmental indicators coming from combination and processing of data projected onto statistical units. Okay, let me explain these Matryoshka boxes. So starting from the larger box, we inventoried at the beginning 54 datasets in total, because different scenarios, different use cases. At a certain point, contemporary to the definition of the user requirements, there was a data inventory asking the pilots which are the data you are working on and which are the data that you are going to, asking to produce as an output of processes. So after a first investigation, we decided that the initial decision, let's say the most simple for us, was to adopt a criteria to say, let's forget about the multiple source datasets and just focus on the datasets which come as an output of the processes made by the project. But this is, let's say, a little bit against the Inspire principle to try to introduce Inspire as close as possible to the source datasets in order to take the maximum benefit from these harmonization principles. So from these 54 datasets, we focused on a subset of 37 datasets to be harmonized. The other 17, meaning, are mostly base maps. So not, I don't want to say not falling under the Inspire application, but not interesting for our harmonization purposes. So from these 37 datasets, you see here the third box is 34 different datasets, meaning that sometimes one dataset has been used in more than one use case or in more than one scenario, because the project, the scenarios, the use cases are a combination of steps and conditions fulfilling some certain user requirements. So that's why the same dataset can be used in different use cases or scenarios. But then out of these 34 different datasets, there were 11 different transformations, meaning that, having in mind, we used ALE for this exercise, that out of these 24 different datasets, 11 have been produced, have been transformed using transformation ad hoc created. But then for the other 13, there was a very easy reuse of the transformation, like, for instance, because we had different pilot areas, for instance, so using basically the same transformation to produce additional datasets reused in different pilot areas. This is the meaning. And then the last subsetting was the 6 different application schemas, because we used the same, okay, 6 different application schemas required 6 completely different mapping each other. But then from using 6 different application schemas, we set up 11 different transformation with some little adjustment to take care of the specific conditions of the use case dealt with. So these 6 different application schemas are these ones: land cover vector, land cover raster, in brown character color, natural risk zones core and geology core will be presented in the next presentations. And then statistical unit vector and population distribution demography. These are the 6 different application schemas that have been used to produce 11 different transformations to harmonize 24 different datasets used 37 times. So let's start with a short example of how we use the land cover raster to produce which is the acronym, Carlo, for HRL, high resolution layer soil sealing imperviousness. It is a Copernicus imperviousness datasets for 2006 and 2009. So you see, for instance, here, we used 2 datasets, one for 2006, another one for 2009. So 2 different datasets produced, so with 2 different transformations, but very similar each other, because we needed just to change very few parameters in the mapping. So 2 datasets of Copernicus imperviousness for 2006-2009 have been transformed according to the land cover raster target schema of Inspire. And before to do that, the source rasters have been clipped on 5, the pilot area consisting of 5 municipalities of the Liguria region, corresponding to the study area, and these are the names of the 5 municipalities. So there was a bit of pre-processing, making this clip of the huge raster onto the 5 municipalities. You can imagine that in terms of transformation, it doesn't matter at all if you clip on a small area or you can make on the on the wall continental scale. Sorry again. This is the land cover raster target schema, and this is an exercise made, I would say, 2.5 years ago. So we were quite, we also have been invited to present this exercise in one Copernicus workshop made in Budapest, December 2014, I think. We used this is the target schema, land cover raster. This is the data type land cover nomenclature that we used. And these are some tips how to properly use the encoding suggested by the technical guidelines. So we used the option reference to an external file instead of a full, let's say, coverage option. There is this possibility to use this reference to an external file. I will explain also why we use this. Maintaining the original GeoTIFF format of the file. For this implementation, the following instructions have been followed. The Annex J, which is encoding rules for TIFF and JPEG 2000 file formats contained in the data specification. And then two annexes, the Annex C, resource identifiers, and Annex D, encoding of file-based data contained in the document D27 guidelines for the encoding of spatial data available on the Inspire website. These are just two snapshots of the documents we referred to make this transformation. Of course, you can. This is just to show the usual matching table in which on your. This is for the feature type. On your left-hand side, you see all the elements of the raster, land cover raster application schema downloaded from the Inspire website. And then on the right-hand side, you see our source, that the corresponding fields filled in for our Copernicus datasets. In particular, I want to mention the range set attribute, for which we used a very, let's say, straightforward approach allowed by AIL, which is the possibility to use, in order to encode, this is for the data type, for this range set, we used a CSV file in which we reproduce each row contains the values that have to be provided for the mapping, including the URL of where the GeoTIFF file can be publicly accessed. And so these, thanks to the functionalities of AIL to import this CSV either for source schema and also for source data, you can have 1,000 of rows, and for each of them, then an instance of the GML file is created. Okay, so extremely reusable and working. This is how with HAIL has been mapped these things, and this is the validation with XMLSpy. Then, here, an example of how we harmonized the datasets consisting of the census tracts and related ISTAT is the Italian National Statistical Institute, census variables, using Inspire target schema, statistical unit, and population distribution. Just to mention that thanks to this exercise, we are now, let's say, by chance, incidentally, in a congress this spring, we met. I was together with the president of the National Institute, and he was not aware of this exercise that we made on their dataset. They are working on Inspire, so they are proposing a meeting to share, let's say, approaches and to see if and how the work made under this project can be helpful for their obligations. Sometimes it's difficult to obtain this kind of meeting at high level, but it seems that the hierarchy is working properly, so we are in contact with the technical people now doing this exercise. So everything is documented in the project website, starting from the download of the source dataset, which is this is the website of the homepage of the Italian National Institute for Statistics. These are the two zip files that we downloaded, the zip file containing the geometry and the zip file containing the data for population distribution in this case, because we started from, let's say, for the most simple example to map the population distribution. But then, following this approach, reusing this approach, instead of having with the same geometries of the statistical units, like the census tracts, which are the most detailed available in terms of in a municipality, you can have many polygons representing census tracts. So they provide a more detailed info, and these in some of the processing that Giorgio mentioned, the experts preferred to use this detailed information of population distribution available at census tract in order to combine them with built-up area, some other data coming from Copernicus in order to derive indexes and datasets useful for the purposes of the use case. So we went back to this official population distribution, which was by default one of the input dataset of the project that had been harmonized. So we downloaded this source file. It's important to focus on this aspect because I will come back to this at the end of my presentation in a few slides. These are the data, the source data deployed in QGIS. So the shapefile plus with the statistical, you see we have 5 municipalities, but you see how many polygons representing these census tracts. And then in the attribute table, you see some data related to the population distribution dataset downloaded from the ISAT. So these are the source datasets viewed in a GIS environment. I think you are already envisaging what I'm saying in a while. Few information. You see how important when you approach any kind of data transformation, how important it is to have documentation about your source schema. This is a table in which all the attributes that you download in the zip file are very well documented in order to support, to help you, to facilitate your mapping exercise, first of all, filling in the matching table. And these are the tables, the data themselves available. So now back to what, so we came to the question, what Inspire is offering to make this harmonization exercise starting from this kind of data, having in mind that there are, at the end, on the same geometries, not only the population distribution data, but, as I mentioned before, some environmental indicators like built-up areas available from the Copernicus data. So there is the combination of the two teams, statistical units and population distribution demography. This is the overview of the statistical unit feature type. For and this is a more detailed overview of the UML package of the statistical unit vector, because it's available also another schema raster, also in this case. So here we can use statistical units to map the geometry. Then when we want to go to the data, we have, you know, the story. Unfortunately, I was not able to attend yesterday the 2 workshops on statistical units, so I don't know if new outcomes came out from that. But then what you have, so you have not a data type here to deal with the attribute, with the data themselves, but you have another schema in which you see all the classes, how you have to use these classes to transform your information, and then you have a link with the geometry, with the statistical unit. So this red box here is the feature type on top of here, inheriting all these classes. So at the end, when you have 2 schemas, at the end you produce 2 GML files. This is a screenshot with the code lists used. It's very rich, this PD schema to allow to take into account all kinds of statistical information. Here is just a list of in which we started with the population distribution, but up to this row there are all the other data sets needed for which we use the same harmonization approach, which are the artificial area and the built-up area in the municipality and the census tracts and so on. These are, again, the combination of the source dataset available from in QGIS is extremely simple to associate, to combine the geometry with the table of the population distribution or of the indicators. So then, when we, with all this information, with all these ingredients, we came out with we produced the harmonization according to the approach presented. So we produced, this is one matching table for statistical units vector on the left, how we mapped on the right. This is the other mapping table for the population distribution demography, and then how we mapped all the elements. But at the end, what we had, and I suppose that any Inspire implementer working in the same field, at the end you have two GML files that if you want to use, for instance, in a GIS environment, you cannot view the data in terms of, you have to combine them with some processing behind. But when you have these two different entities, you cannot have the same view like this that you have in the source data. And the fact, of course, there are several discussions ongoing. For instance, there was a proposal so far discussed in the thematic cluster, instead of having the combination of the two application schemas, to have because the population distribution application schema has no geometries in it. It just has an association with the geometry provided by the statistical unit. But this association coming to another schema requires that in order to view the data in a GIS environment, you have to use some specific workaround or processing around that. So one possibility was discussed so far, but as far as I know, not yet solved, was to modify population distribution in order to import, not just having an association with an external feature type of another application schema, but to import all, to embed in the population distribution schema all the geometries contained in the statistical unit. And this is, for instance, one of the workaround used by some user to view this data, this harmonized data in this case, into an ArcGIS environment, is in this post of the thematic cluster of, I think, 1 year and a half ago, in which is described how to use the GML, to import the GML in ArcMap, and then convert the GML of the population distribution into a table or an Excel file, and then so making the reverse. So this is still an open issue, but at the end, it's one of the issues still open in the Inspire community in order how to, you can imagine how statistical information constitute a very hot topic in Inspire, and of course this was an initial contribution, but there are much more discussions ongoing. Also with Eurostat, now it's becoming the use of TJS, table joint system services, as an option to better produce this. So the discussion is on a higher level, and we as soon as a working option also to deploy the data in a GIS environment, we will be happy to use and to test. But for the time being, in terms of formal conformance, we made the exercise required by Inspire. And that's it. Thank you for your attention.
Then I invite Manuela Caronio from Consorzio Lama. She will give the
Where is?
Presentation about the real experience of harmonized data in chiudi questo. Ok.
Va?
Manuela, the floor is yours.
Okay. Good morning. I'm Manuela Corongiu from Consorzio Lamma, which is a partner inside the LIFE+IMAGINE project. And today I'm going to explain some issues and solution encountered during harmonization process, taking into account the Landslides Scenario. During the harmonization process, we start from different datasets of the same pilot application, and so we had considered the landslide dataset and then geology dataset, and also critical events at meteorological level that triggered the landslide events in a specific time, and also the plan, the PI map, that means the plan, the hydrogeological asset plan for the hazard area. So obviously our objective during the harmonization process focuses toward two basic INSPIRE data teams. The first one is the geology team, because we have the need to define the physical parameterization of landslides object. And on the other hand, we have to consider how to classify the hazard areas, and so independently from the kind of the event that characterize a specific landslide, we take into consideration all the area that is characterized by a landslide. And so our target schema in this situation is the natural risk zones. So the harmonization process is being carried out twice. The first one toward the geology, and the second one toward natural risk zones. In that case, we see the pilot application, the territory of the Tuscany regional administration, but the same process has been made for the Ligurian region. If we start from the basic assumption, as Giacomo said before me, that is, INSPIRE should be as near as possible to the source datasets, and so the processing change should be as shorter as possible. This assumption, starting from a data provider point of view, means that archives should be designed at start, since their design and management, taking into account interoperability requirements, adding them, putting them together with the institutional requirement that motivate each single special data set. Because, for instance, a practical consequence about this double requirement toward inspired and toward basic administration requirement needs to choose, for instance, about the spatial reference system among spatial reference systems that are allowed by INSPIRE. In Italy, basically, we have some national spatial reference systems that are not allowed by INSPIRE. And so during the harmonization process, we can choose if transform in a pre-process action our spatial reference system, or reproject the spatial reference system during the harmonization process. So the results obviously is the same, but the process is different and have a different impact into the public administration. The harmonization process has been made by basically 3 steps. The first step is the matching table. The second one is the remapping between the source datasets toward target datasets. And the third, the physical transformation of our data. And during this process, some issues and milestone choices emerged. First of all, during the matching table, the first question, starting from a data provider, is if your actual structure is oriented to an interoperable target inspired data teams. Because the correspondence, the link between the Inspire application schema and the local application schema is not so easy one-to-one when you compile the matching table. Also, starting from the source datasets, some choices are due to the federal system. In particular, for Landslides Scenario, in Italy, we refer to the IF inventory national database on landslides. But when each regional administration had implemented this inventory, has personalized some characteristics about the content is the same, but the choice has been different depending on, for instance, the spatial components that you chosen or the spatial model that you define, or also relating to the type of the movement defined inside for a landslide that is encoding for to answer some specific requirement inside a regional level, or also the state of activity. Moreover, in order to define the Landslides Scenario inside the LIFE+IMAGINE project, we have to combine different datasets also inside a sole public administration that combine data that come from repository datasets combined with, for instance, the landslide layer with other kind of datasets at a geographical basic level, at regional, so administrative boundary or geology or urbanization plan and so on, with another kind of datasets that refers above all to dynamically study and analyze each specific event on landslides in an ex-ante, ex-post analysis. Another choice is due to the physical platform that each data provider choice in their specific services. For instance, there are differences when you combine data set coming from different data provider, even if the content is the same, but when you have a different system of identification or spatial extent of the data sets. For instance, some data sets are divided by municipality, the other one are divided by river basin, and so on. Also spatial geometry impact to the definition of to the comparison with different type of datasets. For instance, the definition of a landslides as a complex area where the sub-areas define each type or zone of the movement, such as the positional area, collapsed area, and so on. And finally, the spatial and temporal accuracy may make the spatial data set, even if describing the same contents, basically to the data set a little bit different. Moreover, starting from the HAIL software that we have used to harmonize our and transform our data set, we encountered some difficulties, some issues related to use and start from complex data sets that need, for instance, spatial intersection on the fly, but this kind of tools is not allowed at the moment inside the HAIL, and so in that case the solution is pre-process the data set you want to harmonize. So in that case, in the case of the spatial intersection, do the intersection before remapping your data. In another situation, some requirements of Inspire that don't impact with any other requirements of the public authority engineering process is too expensive to follow this requirement of Inspire before the transformation. And so in that case, for instance, the solution has been the customization of HAIL software, for instance, to reproject the geometry on the fly, so change the spatial reference system during the remapping. And another example is to read natively the spatial light data extension, so the SQLite extension that is the basic physical format for the database, spatial database in Tuscany Regional Administration. Finally, another issue is that for each harmonized data set, you have to compile a new metadata for this harmonized data, and you have to do this in a specific different step. And so the suggestion in this case is there should be a combined software that will be able to output directly metadata compliant with the harmonized data set. Some conclusion. Harmonization process raises some critical issues for designing and manage complex database, and at the same time deliver Inspire compliance service if this is an institutional task in a public body. But anyway, because there are some choices that you have to keep on time. For instance, you have to plan what kind of transformation you have to do, and so what pre-process before transformation and what on the fly, and taking into account that the processing change should be as short as possible. So the harmonization process over time require an effort in terms of resources and in terms of time to plan directly, since you design your data set toward an interoperability focus. And even if the tools that we are available to harmonize our data are easy to use, it's not possible to avoid the in-depth knowledge of the Inspire data specification to do this transformation. And finally, technically, if you want to define an impact for the landslide scenario, you have to take into account two kind of basic two kind of data sets as a source. The first one comes from a repository data set, and the second one are basically for model and analyze your data dynamically. This kind of data set basically are managed by different services in the regional administration. So that is, thank you for your attention. If you have any question.
Okay. Good morning to all. Have the role to present some result of the project. So I not talk about the harmonization. I think the two previous presentations have spoken a lot. So I concentrate more on what we have done with this data and what is the advantage and the potentiality of the inspired data for some application and for future application. Just to show you very quickly, we see that we have two mainly scenarios, one for landslide, one for soil consumption, in two different regions, so we not spend more. Also, George will show you the different location. But we have to remind that we have also a coastal sediment budget due to landslide event. So we are analyzing the coastal management, integration coastal management event like landslide in 2011 is a specific landslide event in the last 10 years that we take in account, and we analyze which is the impact of this landslide on the coastal. So we have analyzing the budget in a specific physiographic unit, and you can see in the picture that here there is the sea, and after the event we have the beach. So we have a lot of material that we have moved in these events. What we have realized with this data, mainly the indicators, the impact indicators, the environmental impact indicators, the socioeconomic impact indicators. For soil consumption, we have developed and calculate some national and local parameter like soil sealing area, building up area, soil sealing area regarding the population, the artificial area, how many area is occupying by the human infrastructure, the density of the population regarding the soil sealing, and some metric specific parameter, especially for the pilot, like the largest patch index, residual patch size, and the age density, and the mean patch area that describe well how the municipality change in time. So we have analyzed three different steps, one for 2006, 2009, and 2012. So we have a rate, a trend of the soil consumption in this area. But quite important for us is also taking consideration that in this process we starting to use the Copernicus Imperviousness high resolution layer. We using this layer, we enrich this layer with the building. The regional building is used, the municipality building is used to enrich the quality of the imperviousness layer, and the new layer developed after this process is the new Imperviousness Inspire area resolution layer. So Giacomo showed you before that this layer is harmonized considering the length cover nomenclature. So at the end, we have a new layer ready for Inspire. In this case, we have also taken consideration that we have also applied the soil consumption to evaluate how to change the land cover in different time, have different characteristics. So we have also analyzed how to change the territory in time. So also this gives us a view of the impact of the change, the trend change in the time. This is more or less the index that we have calculated for soil consumption scenario, but then we have also landslide scenario. So for landslide scenario, we have calculated specific index to identify how many landslides we have in a municipality, how is the impact of this landslide in terms of the density and the number, but also we have analyzing how this landslide is interact with the transport network, so the infrastructure, communication infrastructure with the residential area, so which is the impact of a landslide on the building, on the population, and how many population is posed by landslide. And then we have calculated also the impact of a landslide on the cultural heritage. Also, considering, especially in this area of the Liguria, we have a specific terrace, agricultural terrace, that considering a cultural heritage for that, because representing historical patrimonial of this area. So, and then we have also at the end calculated how this impact cost, so which is the estimation, the cost estimation of the landslide along the transport network, considering the building and the population. So we try to estimate some economical elements. Go very quickly, but show you what we have calculated, because this represents one of the steps and the result of the project. For example, we have calculated for each transport network, which is the critical elements. In this case, you see in different color, which is the critical elements of the roads and the railway. So this gives us an overview of the impact of a landslide on the environment in this case. We have also calculated the exposition of a building, considering the residential and so private building and public building, like hospital or policy headquarters, something like that. And then we have also calculated the exposition of the population. So you have to consider just in the Liguria pilot site, where we have 2 municipalities, we can estimate that more than 56% of the population building is located in the high hazard landslide area, so to take in account. And also that more than 45% of the population live in this building, so have an effect, especially have an effect with the 2011 events. So most of these buildings are destroyed or have damage related to this event. So anyway, give us an overview and an aspect to make a very accurate environmental impact analysis due to the landslide. Just to go quickly to show you the last 2 or 3 elements. We have also exposition of cultural heritage. In this case, we see that the San Bernardino Sanctuary is the unique historical building that is affected by the landslide in 2011. But anyway, we have a list of cultural heritage that are located in these 2 municipalities. Of course, the calculation have done also in the Tuscany. We have some other tables that explain this one, just to show very quickly which is the content of our impact analysis. And then we have the exposition of agriculture terrace. So I explained that this terrace representing historical element, representing patrimonium. So we analyzing which is the terrace affected by the landslide and which is also the relation between the terrace and the landslide, because in some case, some people suppose that the abandoned the terrace are a casualty for a trigger element for landslide, but this is not true. It's not really true. At the end, we analyze that more or less the terrace are affected by landslide independently if are abandoned or not abandoned. In some cases, we have a little bit difference, but anyway, we not go in detail on this aspect. All this data, anyway, are obtained with a combination process. So, in some cases, we have data harmonization. We see that most of the input data, like hazard, landslide hazard map or landslide event, but also some other elements that representing the vulnerability, like the building, like the population, as harmonized in ICZM format. And this helps us to integrate in a unique system and to obtain the result, especially to obtain the risk level. So in some cases in the system, the input harmonizing layer with some specific vulnerability elements are integrated to create the risk the risk scenario. The risk scenario is represented by the impact, the indicators that show us a real effect of a landslide. So to go to see which is the advantage and potentiality of this system. So you can see in the last version of the client, just sort of finished maybe yesterday evening, all the process to calculate the indicator are integrated. So, and this is representing a very advantage because the common process that can apply at different geographical context, but also in a different time window, if changing, if I have available the imperviousness for 2014, I can including in the system and I can perform a new analysis on that, representing a very good advantage because the system are set up to using a common layer, the INSPIRE layer. So the attribute that we use in the geoprocessing are the same if we're using the INSPIRE layer. And in a way, the double pass tools are reusable in other contexts in the EU. It's not set to just to working in Italy because more or less the analysis that we can perform, especially the buffer around another area or the intersection or the specific index calculation, and we can use it in other system or in other context, but this is possible because we're using a common INSPIRE layer. Just to look with some potentiality. Of course, also here we see other screenshot of a landslide analysis, so more or less all the use case shown by George in the first presentation are integrated in the client, so you can perform the soil consumption process, the landslide process, the coastal sediment budget analysis, and then you have also the possibility to use the single double PS. So the double PS is more or less are reusable in other contexts. So which is the potentiality? The common input and the output layer can be used in another web and mobile application, for example. So if you know that the output is perfectly in line with the SPY, you know exactly which is the data model of your data. And you can perform your application based on that. The methodological approach based on the inspired layer can be improved the risk analysis chain. So in some case, we have to consider that the impact analysis that we have performed have a new life based on the combination of this layer that before is quite complex, required a lot of time because in some cases we have a different coordination reference system, different attribute in different contexts. So in this case, also the methodological approach can be exported in other contexts. And the last one is that the LIFE+IMAGINE sediment budget or integrated coastal zone management case represent the first operative example how we reuse this layer, because in some cases we reuse the landslide harmonizing layer to reproduce another process like the sediment due to the landslide. In fact, the landslide is used as another input and also the result of a landslide impact are used to build is some activity that we are in progress in this period to realize a new indicator of impact along the coastal due to landslide and due to the movement of these sediments along the coast. I think this more or less is some elements that's also useful for starting to discuss or to have some feedback from you, which is for you the potentiality to use some result like that. Thank you. Questions. Oh, of course, I forgot to say that there is a poster in a poster session of Emanuela that explains the process of a landslide harmonization in Tuscany. There is also my presentation Tuesday afternoon where I explain more in detail the landslide analysis and the landslide harmonization viewed by the national agency, not at the regional level. So in some case, when she talking about the IFI, we are the responsible for the entire IFI database. So this is the national database, and we harmonize the national database. The regional have a specific evolution of this one. So you are invited to follow these two other presentations.
I guess my question relates to the use of the Inspire specifications. How important was that, or how important were the Inspire specifications in being able to produce your final results, your hopefully reusable tools, et cetera? Because obviously you had quite a lot of transformation work required from the original data sets before you could come up with, for example, your landslide application. Yeah,
I mean, the data specification, I mean, also, Giacomo, if you want to say something. But anyway, I think so the data specification representing the pillar to start the harmonization. It's the unique layer that we have, the unique document that we have to start to produce something. But then there is a lot, Manuela showed, there are a lot of issues that encountering when you're starting to transform your data. If you're looking to, you have to considering that in some cases the data transformation is designed just to look at specific themes, but in some cases our database is not designed for specific themes. In fact, if you're looking to the IFI inventory, in our database, we have also information regarding the damage. We have some information regarding the casualty. And this is not manageable by the natural risk zone or by the geology layer, because it's something else. So in some case, we have to start to produce something, and then we're working to adjust your activity. I think so.
Roger, one practical example reply to your question is that in the let's say in the geoportal of this project, there are a set of WPS available for users, and one I think very interesting is in one of the scenarios in Tuscany region, in which Manuela is much more involved, there was the necessity to produce land cover change map from one data to another. And this WPS is, I think, is almost to be finalized because the project is ending in a few months, to be able to produce this kind of output map, allowing the user to upload, to use. For the moment, is working with a set of pre-uploaded datasets in which you have different land cover datasets at different dates. You can select two of them, and then you have as an output again the GML producing the difference between the two land cover datasets. Of course, these pre-uploaded datasets have been checked in order to be consistent and let's say ingredients for which the transformation can work without problems.
There is another example that we use in the Landslide. We're using the routing WPS service. So this routing is based on the transport network harmonized layer. So when you have this type of a system, you can apply or you can apply in another context, not only for Landslide, because the routing WPS is something that is useful also for Zurich's purpose or some other purpose anyway.
Just a quick follow-up. How easy or difficult was it to ingest the Copernicus data into your applications? I mean, is it well documented and an easy-to-follow procedure, or do you need real special knowledge in that?
It was, regarding the transformation aspect, it was extremely fast and simple because we used the option provided by the encoding of the data specification to reference it as an external file. So there is one field in one of the elements of the application schema for which you have to provide a resolvable URI in which you can publicly access and download your GeoTIFF, in this case the GeoTIFF file. But this was let's say a fully conformant option to encode these kind of huge raster files. The other one, let's say more complex, is to use, instead of this external reference file option, the full coverage geometry in which all the pixels of your raster file are properly encoded according to the coverage option provided by Inspire, but we used the first one. So in terms of reuse of this data, it should be much better, the coverage option, because in this case you have a sort of, let's say, more similar to some metadata-like approach rather than the data themselves, but you can reach them thanks to this mandatoriness of having a publicly available GeoTIFF file. Just, Giorgio. Just a last note. I don't know how many of you are familiar with the LIFE projects. LIFE is a program of DGM for specific nature and related aspects. This was a strand for the strategic horizontal aspects like spatial data infrastructures. But according to the Article 14 of the new common provisions, each dataset produced in a LIFE project has to be INSPIRE compliant. And we believe that the experience that we made in this project can be useful for many other colleagues that are sometimes in the nature. Many of the LIFE projects are dealing with other kind of works related to nature conservation. Not often there are people in the consortium skilled to work with INSPIRE. So we believe that the experience that we made can be offered to all the other projects willing to achieve these. It's a contractual obligation in addition to the benefits that we know that harmonizing datasets can improve the overall environmental aspects. So this is important. For instance, there was I didn't mention because in my presentation because there was nothing special to show to you, but the use of the land cover vector schema in which we harmonized the full, even though the few municipalities were in the pilot area, we harmonized the full regional dataset. And now, together with GSIG, we are in contact with Regione Liguria because we are supporting them in fulfilling their INSPIRE obligation thanks to this project. And last but not least, we forgot to mention that there is this new scenario that Carlo mentioned of all the input coming into this more integrated coastal zone management. We will use also the sea regions. We are going to approach this new for us, but we will have a few datasets to harmonize according to this theme, sea region, and all results will be available on the website.
About INSPIRE, I wish to invite you at lunchtime. In which room, Vlado? Here, in this room, there is a section about training for INSPIRE, and we will present some of the modules that are included here. So thank you for your coming here, and hope you appreciate this what you learn. Thank you very much.